guys, today we are going to look at some more multiplying of polynomials. The two that I'm going to show you today are just special cases. And so let's just go right into it. I have a love-hate relationship with this lesson because students get so caught up in trying to remember methods, but it's just a pattern, and here's what I want to show you. So the first one is called the square of a binomial. Okay, so that's what it's called because here's what happens. And I'm actually going to do a couple of these to show you what happens. I'm going to start with a pretty easy one. I'm going to do x plus 4 to the second power. Okay, so first of all, the answer is not x squared plus 16. You cannot distribute a square if you have a plus inside, right? Like if it was 4x squared, sure, that would become 4 squared and x squared. But we're adding and not multiplying, so we cannot do that. Do not do that. It will be wrong. We know that anytime we square something, that means you're multiplying it times itself. So I'm going to attempt to appeal to your sense of reason here. And I'm going to work this one out just the exact same way that we did yesterday. I'm going to use the distributive property. Okay, so I'm going to do x times x, which is x squared, x times plus 4, which is plus 4x. Then 4 times x, which is another plus 4x. And then, of course, 4 times 4, which is 16. So we see that our answer, we do still end up with those two like terms there in the middle. So the simplified answer would be x squared plus 8x, right? 4 plus 4 plus 16. Okay, so off the bat, it doesn't look like there's anything special, right? So you don't have to remember this shortcut, for lack of a better term, that I'm going to show you, but I promise it's going to come in handy a bunch of times, right? Otherwise I wouldn't just be showing it to you. So you just need to be familiar with what happens when you square a binomial. So I'm going to do one more, and I'm going to show you the similarities, and then we're going to talk about how you can apply and understand what they want us to show you in this lesson. So I'm going to do another one. Same thing. I'm going to square a binomial. So this time I'm going to have a leading coefficient that's not 1, and I'm going to use a minus sign. Okay, so I'm going to do 3x minus 2 squared. Same thing, I'm just going to do, that means I know that it's 3x minus 2 times 3x minus 2, right? And squaring the binomial, I'm going to do the distributive property just like I did before. So I'm going to do 3x times both of those terms, which would give me 9x squared, and then minus 6x for my first one. And then the same thing with the minus 2. Whenever I distribute it, that's going to give me another minus 6x. And negative 2 times negative 2 would be a positive 4. And again, I can see that the two terms in the middle are like terms, so I can combine those. Negative 6 minus 6 is a negative 12x, and then plus 4. So that would be my solution for this one. Okay, so I want you to notice something that happens. Let me turn on my highlighter yet. Okay, so see here we have our first term. And then look at your solution. Okay. And I'm going to, y'all know how I hate formulas, but I'm going to write this down because it might help some of you guys, which is good. It's good. I just don't like formulas. Okay, so my first term, and we're going to call it A. And I'm just going to do plus for right now. B squared. Okay, so think of this right here as the quote-unquote formula for squaring a binomial, okay? So notice your first term is just squared, right? X squared. 3x squared is 9x squared, right? So it's just the first term squared always. A squared. Now look at your middle term. Your middle term, in this case, the 8x and the minus 12x, is whenever you take, I'm going to change my colors again, when you take these two terms and multiply them, but it's doubled, right? X times 4, of course, is 4x, but whenever I double that, I get 8x, right? 3x times negative 2 is negative 6, right? If I multiply that, I get negative 6x. And then whenever I double that, look what you get, negative 12x. So if we're looking at it in terms of a quote-unquote formula, it would be 2 times those two things being multiplied times each other. Right, it's twice their product. And then, of course, the last term, we can see here, again, it's a similar thing. 4 squared is 16, and negative 2 squared is positive 4. So it's plus the last term squared. Okay, so that always happens no matter what. Now, do notice the minus sign is obviously a little different. If it was a minus b squared, the only difference here is that instead of, and we see that right here, instead of adding right there, it's going to be subtracting it. And that's because that's going to happen every time with your negative. Okay, so that's the, I hate to use the word formula, but I mean, if you want to think about it. So here's an example with the shortcut. So if I gave you, shoot, I don't know, let's do something weird. Let's do 4x plus 8 squared. Okay, so instead of using the distributive property, okay, again, feel free to use the distributive property on this. It's not going to hurt my feelings if you don't, and if you don't use this method, but you're going to want to be familiar with it. Here's what you're going to do. I know it's the first term squared, right? So that's going to be 16x squared plus, because I can see I'm adding here in the middle, I'm going to multiply these two together. 4 times 8 is 32x. And then it's always twice that. Because if we look back at our distributive property, we can see that, hey, there were 2 of them. Hey, there were 2 of them. That's why it's twice that. So twice that would be, of course, 64. Plus the last thing squared, which is just 64 again. 8 squared, 64. So that's it. Okay, so that's using the shortcut to squaring a binomial. And that, again, that shortcut only works whenever you're squaring the binomial. Okay, so that's the first shortcut. That's considered a special case. That's going to come in handy actually when we do these fun things called conic sections and completing the square, because it is a square, right? You're doing that. All right, so here's the second one. I actually absolutely love this one. This is the, well, my brain is turned off. This is the difference of squares. Okay, so again, I'm going to start off like I did a minute ago. I'm going to apply what we've learned yesterday, and then I'm going to show you the shortcut. Okay, so this one, again, is pretty straightforward. Let's start with another easy one. Let's do x plus 7 times x minus 7. So this time I'm not squaring it. These two are not the same binomial. When you're adding 7, when you're subtracting 7. But notice the two terms are exactly the same. 2 x's, 2 7's. Okay, so you see that's the pattern. They're the same terms, but you're adding in one of the parentheses and subtracting in the other. The addition sign does not have to come before the subtraction sign. So using the distributive property, here we go. I'm just going to distribute that x. So that's going to give me x to the second minus 7x. And then I'm going to distribute that 7. So that's going to give me a positive 7x. And then minus 49. So using the distributive property. Now notice what happens on your like terms in the middle here. Negative 7 plus 7, that's 0. So it adds out. And all I'm left with is the x squared and the minus 49. Sorry, apparently my phone is still on. There we go. So that's it. That's the answer. X squared minus 49. The two middle terms just happen to add out. Gonna do one more, and then you guys will probably catch on to the shortcut for this one pretty quickly. So here's another example. 2x minus 5, 2x plus 5. Okay, again, my terms are the same. 2x, 2x, 5, 5. But the signs in the different and middle are different. A plus and a minus. Still going to use the distributive property again here. Right, so you get 4x to the second plus 10x. and then distributing that negative 5 here, that's going to give me negative 10x minus 25. Look what happens again. Those two middle terms, 10 minus 10, that's 0. They add out. So I'm left with 4x squared minus 25. Okay, so let's look at the quote-unquote shortcut. I'm going to use a's and b's again. That's really common in algebra. So a plus b, a minus b, right? The two terms are the same, but the signs are different. Please notice what's happening. First of all, we know we're not going to have a linear term. We saw that here both times that it equaled 0. That's going to happen every time. Notice that your first term, x, of course, is squared, right? 2x here, 4x squared, so it's squared. So whatever my first term is going to be squared. Notice that both times the middle sign is a minus. That's why this method is called the difference of squares, because you're taking the difference. It's a subtraction sign. And then again, notice how my last term, 7 and 7, happens to be 49, right? 7 squared is 49. 5 squared is 25. So it's minus b squared. That's why it's called the difference of squares, because you are subtracting a squared and b squared. Okay, so let's look at one of these where it is using the shortcut. Let's use the shortcut on this next one. Goodness, what do we got? This one's fine. 3y minus 5, 3y plus 5. Right, I'm just going to let you know I never use the distributive property on these just because it's way too much trouble, and I know that middle one's going to go away. So I see my first term is a 3y, and 3y squared is 9y squared. I have a minus sign because these are different, right? So I know it's going to end up being this particular method. And my 5's, 5 squared is 25. So 9y squared minus 25. And that